super video, is there a logic to get the opposite? Some wrong ways that only tells you x is equal to 0. Let's have a look. Starting with x squared is equal to x, I'm going to subtract 1 from both sides first. And we get x squared minus 1 is equal to x minus 1. And I will factor the left hand side as a difference of two squares. And we will have x minus 1 times x plus 1. And that's equal to x minus 1. And now notice, we have x minus 1 on both sides. Let's go ahead and divide both sides by that. Cancel, cancel, and we get x plus 1. Well, this and that also cancel, and we get 1. Right here, let's go ahead and subtract 1 from both sides. And ladies and gentlemen, we end up x is equal to 0. So of course, this is not correct in the sense that we are missing a solution, because when we divide both sides by x minus 1, well, that could be 0. In fact, x minus 1 is actually a factor to the original equation. The correct way to do it is starting with x squared equals x. Subtract x from both sides. Then factor out an x. And you see we get either x equal to 0 or x minus 1 equal to 0. So this factor is actually 0. Cannot divide both sides by 0. It's bad. So you actually have two answers. 0 or the other one is 1. Just like that. Okay, that's not so bad. You might be wondering, like, maybe when we divide both sides by an expression, a factor, or variable, we just have to make sure it's not equal to 0. We're just missing a solution. We still have a solution, so I can still get some partial credit, right? In fact, 50% of the partial credit, right? Well, not so much. Take a look right here. Sometimes you just have to be super careful. Suppose you have x squared equals x. And let's say you want to solve this equation by taking the logarithms first. Let's take the common log, and this is technically log base 10. Once you have the log, you can put a 2 to the front. That's a power in the front. So you have 2 log of x is equal to log of x. We have log of x on both sides. Let's divide both sides by log of x. Cancel, cancel. For this right here, it's also cancel, cancel. On the left, we have 2. On the right, this is 1. Well, in fact, it's really horrible, right? Because, of course, this is wrong. But what went wrong? Remember, we mentioned that when x is 0, it satisfies the solution. So, in fact, you cannot even put 0 into log. Log of 0. We do not have an answer for it. You can take the limit as x approaching 0 from the right hand side. That's negative infinity. But log of 0 is undefined, not even with complex numbers. So this is really bad. You cannot have a log of 0. And secondly, of course, if you have 1 instead of the log, this is equal to 0. And we are dividing by 0 on both sides. And we end up with something that doesn't make sense. We are saying 2 is equal to 0. So be careful. And in fact, if you wonder, can we solve this equation by taking logarithms first? Not so much, because log of 0 is not defined. Even though you try to do this property by putting the 2 to the front first, and then subtract log of x from both sides, you only have one answer, because you cannot have 0 inside of a log at all. You can try it and let me know how that goes. But anyways, that's it.